This is Lab 3, The Magnetic Field of a Bar Magnet by Melanie Weaver. To begin, the Earth creates magnetic fields based off of the magnetic poles, which are different from the geographic North and South Pole. Bar magnets act as magnetic dipoles, and the magnetic fields increase when you get closer to the source. For our specific experiment, the X value increased. And you can cancel out magnetic fields from the position or orientation, which was what we did for the Earth's magnetic field. We utilized the PHYS law, even though the PHYS law specifically refers to the magnetic field due to current, but the dipole equations we used are derived from this, and the magnetic moment that I found was 2.9416 amp meters squared. For the experiment, we used a magnetometer app on our phone to measure the magnetic field based off of a bar magnet, and first we had to cancel out the magnetic field due to the Earth, so we just found the value where the X was closest to 0, and then through canceling out different values, we had to find where the magnetic chip on our phone was that specifically measured, which is shown in the diagram below. And then after we did that, we were given specific X value of magnetic field, and we just shifted our phone along to find the distance where I got that value. And then the same for Y components of magnetic field, and then we found an offset magnetic field value of 45 degrees. So for the observations, my equation of the natural log of the magnetic field due to X versus the natural log of the distance was Y equals negative 3.1993x minus 14.346, and that graph is shown on the next slide. And the closer we got to the magnet, the X part of the magnetic field increased, and the off-axis magnetic field that I found was 48.6 microtesla, which was very close to the around 50 that was expected from where I am. And the chart of values for the off-axis field is shown below. So this is the chart of my distances and X component magnetic fields based off of the magnetic fields that we were supposed to find, and here's the graph that I found. So for my calculations, the N that I got was negative 3.1993, which we expected negative 3 because of that proportional value of 1 over r to the third in the equation, so we expected the negative 3 from that. And the natural log of k is the y-intercept of the equation, which was negative 14.346, and k equals mu naught over 4 pi times 2 mu, which mu is the magnetic moment. And then to solve for mu, you can do e to the power of the natural log of k to cancel that out, and you get mu is 2.9146 amp meters squared. So for the coding, first we had to create a function that calculated the magnetic field, and then we had to set observation points and create magnetic field arrows, 2 that were parallel to the axis and 4 that were perpendicular to the axis. And then we had to do another one, which is the offset 45-degree one in the same way, where you create the arrows using the function that you created in the beginning. So this is my computational model. The white cylinder is the magnet. The orange arrows are the on-axis magnetic fields. The blue arrows are the perpendicular to the axis magnetic fields. And the small green arrow is the offset. So you can see that the perpendicular ones are in the opposite direction, all the same magnitude, and same with the on-axis ones there are the same magnitude, and the on-axis is double in magnitude that of the perpendicular because they are all the same distance away, and on-axis is double to the perpendicular value. So for the questions, if you hadn't oriented your experiment to compensate for the Earth's magnetic field, the X component of the magnetic field would strengthen, altering, or it would decrease, altering all further measurements in your experiment. And if you had 2 identical magnets together, the magnetic field would double from a doubled magnetic moment that you got from having 2 magnets. And to conclude, we observed values of magnetic fields. We proved that the field increases when you get closer to the magnet. We visually computed that the same distance perpendicular from the center of a dipole has the same magnetic field, and same for on-axis, and that the on-axis is double the perpendicular but in the opposite direction, and the computed value for magnetic moment was 2.9416 amp meters squared, which is relatively close to the expected value. Thank you.